All right, and we are back in business running a London Marathon today, aka doing the second part of this specimen paper. Hello. All right, let's do this. All right, so here we have a cumulative frequency, which the graph of that always goes up. And what we need to do here, right? A male runner is chosen at random. Find the estimate for probability that the runner took less than 4 hours to finish the London Marathon. So first thing that I noticed is the time is in minutes and the question says 4 hours. So how about converting those? So I can figure out 4 hours would be 60 times 4, 240 minutes. Now 240 minutes is right here. Now you can actually clearly see the lines. So when you use a ruler for this, you will be able to do this really accurately because I can see this value. All right, it's just very straightforward. You use the ruler. Every little square is 2, meaning this is this represents here 42. Now probabilities out of we got 100 male runners. Therefore, question A will be 42 out of 100. Make sense, right? There is a bit of a degree of error there that they probably allow you to do like anything between like 40 and 44 maybe. Right, moving on. Okay, this is the type of questions where students all of a sudden forget they are in the math exam and they write an English essay. No, this is not about you writing a story about what you think is happening here. This is very specific. If they want you to compare the distribution of the time taken by male runners, they essentially want you to compare median. There's always at least 2 marks on this. This one actually has 4 because there's a lot to calculate. And something called interquartile range. All right, now interquartile range. All right, let's try to spell this. Interquartile range is upper quartile minus lower quartile. Now, you might be thinking I am speaking a different language here, but I'm not. Upper quartile is 3/4 of your data, and lower quartile is just 1/4 of your data, while median is half of your data. Am I leaving myself any space here? Right, so sometimes box plots can be used when you're using this type of situation. So you do need to use your table. By table, I mean the graph for this. And you do have to, this is going to take a little bit longer, right? You're going to have to compare this. So let's, the best idea for this, however long this is going to be, let's do some work here and create ourselves a little table. I'm thinking, I'm gonna say median, not medium, those guys, median, then upper quartile, lower quartile, and interquartile range, which is the subtraction, right? Maybe red wasn't the best choice here, but wherever. We're gonna go male and female. All right, so let's do this. First of all, median. We have 100, right? 100 the runners. So median will be 50 there, at 50, and now I'm gonna have to read this value. So I hit the graph there, I'm gonna have to read it here and figure out what this is. Now this would go into 652. I believe this goes up into six units each. So I'm gonna say this is 252. I just have a little bit of a bigger graph here on my laptop. There we go. All right, and then for male, and for female, if I carry on, it's there, and that would be 58, 276. Now upper quartile. Now we are talking about upper quartile, which is 3/4, 75% of your data, which is 75 there, 75. So where is 75? Well, here is 70. 2, 4, 6, 8. So it would be there, 75. So it's not gonna be really that. It's not gonna be on the line, but I'm hitting exact value there. That's good. Now this is a little bit painful to watch, I understand, because there's a lot to work through here, but essentially this is what you will be going through. So those are the values there. So let's look at this. I'm thinking this is 2, this is 3, 4, 2, 6. Yeah, I would say like 3, 312, and here 8, take away 8, 92, to like 92, I would say, somewhere around that number. Okay, and then lower quartile. Well, lower quartile is now 25%, so this is on 30, and then 25 would be somewhere here. Hit that value and then carry on with that line until you hit this one. So I would say 2, wait a second, let's see, 400 and let's see, something there, 420 minus plus 360 divided by 2 gives us 390, and I got 1, 2, 3, 4, 5 units, and I got 30 divided by 5 units, so 6. Yeah, that gives me 6. Okay, yeah, sorry, that took a little bit longer than I thought. I just want to double check here something here. 312, yeah, I'm happy with that. And then I take away 6 and take away 6, 180, 188. This is where I wasn't too happy with myself there. All right, 288. Yeah, I think so. Yeah, 12. Yeah, boom. All right, arithmetic. Love it. All right, so there we go. So we got 30 to be, that's gonna be 210, 216, I would say. And my green one, 246 there. Interquartile range for the male, this is, I have 188 minus 1, 1, not 1, 1, 288 minus 216. This gives me 72. For the females, we're gonna go 1, 2, 2, 4, 6. That gives me 66. All right, so I would say that's pretty accurate. It's gonna be up there. Your answers might vary a little bit in terms of like obviously I'm not using a ruler. You should be using a ruler, but I'm trying to be accurate as much as possible. So what you do in questions like this, you basically need to talk about the median and talk about the interquartile range, which demonstrates the spread of data. So what I would say, there's 2 sentences needed there. I would probably say median, looking at the median time for females is greater than males. All right. On average, it takes females a little bit longer to run the marathon. And question 2, I would say the interquartile range of those is larger for males. All right. So the spread of data is a bit bigger for males there. All right, next one. Spent a lot of time on this one, but it does take a long time to draw those things and find out the answer. All right, Marie has 25 cards. Each card has a different symbol. She gives 1 card to Shelley and 1 card to Pauline. How many different ways can she do it? So, okay, so when Marie, when she has 25 cards, she can give 1 of those 25 to Shelley, but then she would have to give Pauline 24 because she already given 25 to Shelley, if you know what I mean, right? So multiplying those two, those are the combinations. So if she gives 1 to her, there's 25 possibilities there, and she gives, there's 24 possibilities for the other one, right? So you're going to have to do 25 times 24, nice 600. All right, next one. There are 12 boys and 10 girls in David's class. He is going to pick 3 different students from his class and write their names in the list in this order that you see over here or over here. Now remember, or when it comes to probability means plus. So keep that in mind. There's going to be some sort of plus there. How many different lists can David write? Well, so for this boy, we got 12. And then we got 10 girls. And then for this boy, there will be 11 now because 1 already has been chosen. So you see how that works? So we got 12 times 10 times 11 plus, this is the or option. And for this girl, well, that's 10, 12, and 1 less girl because 1 less girl was chosen. which is 9. All right, so that's going to be 10 times 12 times 9. All right, let's put this in a calculator. 12 times 10 times 11 plus, open brackets, 10 times 12 times 9, close the bracket, and this gives us 2. I made a mistake. Made a mistake here. All right, one more time. There's gonna be some editing over here, probably or not. We'll see. 12 times 10 times 11. That's 1320, and then I got 120 times 9. This gives me 1080, and this together plus 1310. This calculator is annoying sometimes. 1320 gives you nice and juicy 2400. All right, so that's that one. Combinations. Moving on. All right, so next question is about the slugs, disgusting little slugs in your garden. The number of slugs in the garden T days from now is PT where blah 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 blah. Work out the number of slugs in the garden. All right, this just sounds difficult, but really what we are using is just a substitution here. P1, which is on your first day, this is day 1, will equal to, we use that formula, 1.06, and substitute the value, original value, 200. I don't need to use a calculator for that. I already know it's 106. Day 2, we're gonna go same formula, is just now putting 0.6 there. 1.6 times 106 gives us 12,11236. P number 3, we're going to go with the same option. Put this inside, and we're gonna go 1.06 times 112.36. Calculator, thank you very much. 119.1016. Work at the number of slugs. We obviously do not have 0.1016 of a slug, even though when I was a child I would sometimes chop the head off of the slugs. But I don't do that anymore. So I would say not a curvy brackets. What are you doing? This will be 419 slugs. Nice. All right, question number 14. This is a direct proportion. Okay, so that's a nice one. Pretty much every time now there is a direct or inverse proportion questions. Right, direct proportion. This is the y equals kx. That's the formula, right? This is like when I'm working for 5 hours and I'm getting paid £10 an hour, because this is 1997. I earn the amount of hours I worked times the flat fee, right? And your flat fee is the K, okay? So that's where we comes when it's directly proportional. When it's inversely proportional, I had a moment to think if that's how you spell inversely. This is this situation, K over x. So if I'm painting a room, it's gonna take me this amount of time, but if you hire 3 people to paint the same room, it's gonna take 3 less time to do it, all right? So that's an example of inversely proportional situation. Now, obviously, when it comes to questions like this, you have to kind of first figure out, are they talking about directly or inversely? Now, the word directly, they sometimes don't even use it, so they can say something is proportional to something. That means directly proportional. If it's something is inversely proportional, they will always use this word, inversely proportional. So any other way, if there is no word inversely, it means directly proportional. But Greg, there is D here and N. What is this? You are giving me some Y and X. Well, you have to match this, right? You have to match it. It's very easy. You just look, my formula starts with Y, ends with X. The same way you're going to approach this. This starts with D, ends with N. So you're going to have D equals to Kn. All right? In that case. And if it was inversely proportional, it would be D equals K over N. But this is not the situation. We're not dealing with this one today in this question. All right, so what is this saying in this question? That's I'm just talking a little bit about how that works, right? In terms of directly proportional, if you have this situations. But this question is a little bit different because it says Mary says that when n is doubled, the value of d is multiplied by 6. Now, well, if n is doubled, which is times by 2, therefore your what you end up doing is your scale factor, right? Your scale factor is 2 to the power of 3. The reason for it is because when we look back at this, this is a little bit of my mistake here, because I didn't read the question at the end here. But I read it in my head, I just didn't tell you. It says, is directly proportional to the, I was getting there. Amazing, right? Oh, Jesus. All right, so to the cube of n, which means we have to adjust our formula. This would just be what I gave you an example here. This is when d is directly proportional to n. But this is directly proportional to the cube of n. So we have a power of 3. So that means if something, so what do you multiply by? Well, therefore, if something is doubled, if you multiply by 2, then d is multiplied by 2 to the power of 3, which is 2 times 2 times 2, which is 8. So it's not 6, but 8. All right. So yeah, I was a little bit reckless when it comes to reading the second part. I just saw the word directly proportional. I went totally into like teacher mode and started explaining what is the difference between direct and inverse proportion, even though I should have just focused on that question. But there you go. You know, this is the sort of quality you're watching. So there you go. Right, moving on. Question 15. I think there's not many left. Well, there's quite a few. All right, I think it's 21 question there. All right, so there we go. Carol is a character. Yeah, if you know, don't be a Carol. But in this case, she is running a race. And this graph shows her speed in meters per second after the race. All right, calculate the estimate for gradient. So here we're talking about a gradient of a curve. Now, if this was a straight line, we would have a gradient will be steady. But what we can do, we can estimate the the gradient. All right, we can estimate the gradient at the time 4. Now at the time 4, this is time 4, it would be this value over here. How we do this is by throwing a little tangent here, tangent line. I'm still not happy with that line. There we go, much more better. And how do I estimate my gradient? Well, I need the gradient, basically here is the difference in y divided by difference in x. But what do I mean by the difference? Now I need to find a nice triangle here. I think if I go here, that's gonna be 1. I need to find a nice little coordinate, and I believe if I just carry on that line over there, I can use this coordinate there, because I want a nice coordinates here. So I essentially want to calculate this distance, because this is my distance on y, and I want to calculate this distance, and that's my difference on x. If I can do this, then I will be able to find this distance. So here I'm talking about this is 9, so this is 11, so this will be 11 minus 4. I am gonna call this juicy 7, and here this is between 6 and 1. 6 minus 1 is 5, so my gradient would be 7 over 5. All right, 7 over 5, which is 1 and 1/2. I don't know why they put the dotted in there. There shouldn't really be a dot there, guys. 1 2/5. So there you go. If you are one of those nerds who like decimals, 1.2 for you. Okay, again, depending where you're going to draw your triangle, that's where your answer is going to be, but it's going to be very close to this. I would say probably somewhere between 1 and maybe 1.4. All your answers should be fine. But what I like to do is I like to find somewhere where I have a clear coordinate. Obviously you're going to draw this line with a ruler, so it'll be much more accurate. All right, and then ultimately what you want is you want to, every time when I'm showing you those questions, you want to have a little pause, and then you will want to try it yourself maybe first. Okay, what does it say there? Describe fully what answer to part A represents. Well, if this is a speed in meters per second, so this is her acceleration. This essentially shows acceleration. The part A actually shows a acceleration after 4 seconds, because they ask what is fully answer to part A. So what the part A means? So part A means acceleration after 4 seconds, right? Because they say here at t equals 4. All right, explain why the answer to part A is only an estimate. Well, because the tangent to the gradient could be the steepness, right? The steepness of this tangent. So the gradient, steepness is how we describe the gradient. So the gradient of the tangent can vary. Can be, what's the phrase we would use? Can be steeper or less steep. Or less steep. Now, it could be steep or a little bit more shallow, right? So it depends how you draw that gradient, and therefore that would affect the values of x and values of y. All right, there you go. And now let's move on to the next question, question 16. Now, find the value of that. So let's use a calculator for this. I don't see a way to try to just do 10 to the power of 11. Good luck with that. And then square root, it's not a square root, it's a 5 root. All right, so how we going to do this on this calculator? First, we're going to press the button called math. And then I can see number 5 is what you want. And then that would display that value. I'm going to put 5 in here. And I use the cursors to move. I'm going to put 3.2, then times 10. And how do I put that power of 11? First, I'm going to just press that button, x to the power of 2. So I'm going to get power of 2. And with my cursors, I'm going to go back to it and hover over 2 and replace it with 11. And now I can press enter. Oh, and this is just amazing, 200. So I would say used calculator, the answer is 200. Find the value of 10 to the power of 3 over 4. Just so you know, this is the same as 10 to the power of quarter 3, which is 4 root of 10 to the power of 3. Or you could say this is 4 root of 10 to the power of 3, because, you know, could be different. But anyway, this is something I am going to use a calculator again, and the biggest hint for that is this over here. This means use calculator, especially if it's a calculator paper, right? So we're gonna go 10. Again, what I'm gonna do is I'm going to write this and replace that with 3 over 4. Press enter, and this gives me 5.623 and some other numbers. 1 decimal place is here, therefore 5.6, because this is smaller than 5. Next, all right, so question number 17, bounds. All right, when something is like this, we need to recognize what kind of topic this is. Bounds. This is a bit of a tricky situation. All right, we want to calculate the upper bound for C here. And we got ourselves a right angle triangle. Now, what are bounds? So, first of all, we have some measurement of A. This value, they say it's 8.3, but it's actually not 8.3. This is a number that's been rounded to the nearest millimeter, and this is why it is 8.3. But, so what this means that this number, what could this number be? Well, if it's a nearest millimeter, right, half of it would be 0.05. All you have to do is subtract that value and add that value. So you will get 8.25 and you will get 8.35. Now what I've done here, this is your lower bound, this is your upper bound. Now the definition for the bounds is that if I measured something, this is the first number that would round, this would round to 8.3. Because imagine if I had 8.24 and someone said round this to the nearest millimeter, well, I would say this is 8.2. Right? It's 8.2. It's not going to round to 8.3. But if you give me 8.25, well, yes, this would round to 8.3. So this is the first that rounds up. However, the upper bound, because mathematicians don't want to be dealing with numbers like this, 49999, we just said first that doesn't round down. So this is the first number that doesn't round down. Okay, that's why this is upper bound. So in a way, all you have to do is just look at what they're rounding and half that value, take it away or add it. So for B is not 6.1, it's been rounded to 6.1, which means it's gonna be 6.05 or 6.15. This being your lower bound and upper bound. Why is this important? Why am I saying all this? Well, because how will I calculate C? We know A squared equals B squared plus C squared in this case, right? Because they label the hypotenuse, the longest side, they label A. So I'm adjusting my formula, that A squared equals B squared plus C squared, right? There you go. So to calculate C, I'm gonna have to take away B. So my C squared, I'm gonna take this, move this to the other side. So I'm gonna have A squared minus C squared. Now, if they say calculate the upper bound, that means you are looking for the biggest number possible. All right, so let's think logically what this means. You are subtracting two numbers, but look at the numbers that you have. You have 4 options here. So if I take the smallest number and take away another smallest number, can this give me the biggest possible answer? No, it's not going to give me that. I need to have, for this value, I need to have the biggest possible number. So I want to have upper bound here, and I want to be taking away the smallest possible number, which is the lower bound here. Because if I take something big minus something small, this is where I get the biggest possible answer. All right? So each question would be a little bit different. That's why those bounds questions, they always end up towards the end of the paper. So when you end up to that, you can, this give you a suggestion. I'm getting towards the end. All right, so what's this going to be? This is going to be C squared equals, what's A? A is this. So I'm going to take an upper bound, which is this one, 8.35 squared, minus the lower bound, this one, 6.05 squared. Now, obviously, we are going to, at the end, square root our answers, right, to get the final answer to what this is. All right, so at this moment I am going to try to use the calculator to put all of this on the calculator. So I'm going to put a second function, this button over here. Now whenever you can, open the brackets, keep the brackets, guys. I'm going to put 8.35, close the bracket, squared, and then minus, open the bracket, 6.05, close the bracket, squared, and press the enter. This gives me 5.754997828. This will be enough for you to get the full 4 marks on this question. And I would say, since all of this has been rounded, the values been in centimeters, I would just put centimeters to be sure. All right, so this is it. This is the bounds question. Next. All right, we're dealing with some algebra stuff and surds. This is surds and expanding a double bracket. All right, so when it comes to this, let's do it step by step. This is going to be our first multiplication. This is going to be our second multiplication. Then we're going to have number 3. And then we're going to have number 4. Okay, there we go. So next what we need is to do it. So multiplication number 1 is going to give us root a times root a. Now, just so you remember, square root is essentially power of half, so you're adding those two powers. That's why you might have heard your teacher saying that if you square root, if you multiply two square roots, they cancel each other out. It's because of this. Okay, now multiplication number 2 was root a times minus 2 root b. Okay, so that's just is just gonna join like that. Number 3 is 4 b times root a. So first of all, I am gonna just tidy up the first one, because root of 4, just remember this can be written down as root of 4 times root of b, and root of 4 is 2, so this is 2 root b times a. So times a, I'm gonna write it from the left hand, I'm gonna in the alphabetical order, 2 root a root b. So you can, the reason I'm doing this, so you can see that this value and this value now are exactly the same. One is plus, one is minus, therefore they will cancel each other out. This will cancel. All right, and the next last multiplication, number 4, was, let's have a look, this was root 4b times minus 2 root b, which now we know this is 2 root b times minus 2 root b. All right, so what is this going to give me? Well, this is going to give me simply minus 4b. Now root b times root b, this is the same situation as this one, so that's going to just be b, and 2 times minus 2 is minus 4, so minus 4b. Therefore, our answer is what's left, which is a minus 4b. Bam! Bam shabang. That was a nice and quick one for 18. Next one. Oh, beautiful. Sketch of the y equals cos of x. All right, so unfortunately, this is one of those things that you have to remember. You have to be familiar with your graphs. Now, obviously, when it comes to sine and cosine, there is confusion sometimes with students comes from the fact where they don't remember where it starts, because there's a one graph that starts here, right? And there's a one graph that starts at 1, starts here, right? So which one is which? Now, since you do need to remember this. So I would say try, there's certain things you have to remember. 1066, what's that? Great Fire of London. How do I know it? Is because I've learned it. Somehow that sticked in my head. And so in terms of math, there are certain things, like in history, that you do need to remember. And cosine graph essentially goes from 1, crosses at 90, picks here at 180, then crosses at 270, and stops at here at 360. All right, so there's a 360 here, 1, there's a here value of 180, and minus 1, and obviously there and there and there. I would leave it like this. That's a very nice, juicy, super easy marks if you just remember this and just follow that. Remember, you have to draw the graph between 0 and 360. All right, there is a continuation to this question next here. Now we have a graph that's been defined as some sort of function. We need to do 2f of x. Now 2f of x, anything outside, that means affects only y coordinate. So every y coordinate is going to be multiplied by 2. So if this coordinate is at 3, it's going to be at 6 here. Now if this coordinate is here at 1, it's going to be at 2. This coordinate is going to be again here. This coordinate is at 1, it's going to be here. This coordinate is going to be here. All right, so I'm just picking each coordinate, and now I can draw it. That's it, right? Outside only affects y coordinate. The same way, and it's 2 times, right? Now, obviously, if I had f of x plus 2, that means all the y coordinates would be added. You will be adding 2, not multiplying by 2. But it's 2 times, so we multiply by 2. Anything that goes inside only affects, obviously, the x coordinates. Anything outside affects the y coordinates. Next one, I think, is over this one. And this is the situation. This is inside, right? Only affects the x coordinate. However, this is the one that it's a little bit opposite to what your intuition will tell you, because when it comes to this is the movement, the x minus 3, it's a movement, either left or right. Now, because you see minus, your intuition tells you that this should go left, but actually, those things that are inside the brackets, they always go opposite to what you're naturally thinking. And this is the same way when you were having quadratic equations, right? And you had the x plus 4, x minus 2. How did you solve the equation? Where you made it x plus 4 equals 0, x equals minus 4. And here you had equals 2. It was always, the number was always opposite to that one, right? So the same happens here. Every coordinate is just going to be moving right. This is move 3 units right, not left. All right, so I'm going to count it. This coordinate 1, 2, 3 is going to be here. This coordinate 1, 2, 3 is going to be here. So that's going to be there. Going to be going like that. This coordinate is going to be 1, 2, 3. So it's going to be here. So there, and then over here. So essentially that's what we get. Next. All right, I think this is the last one. No, there's 2 more. So this is this one and the next one. All right, this might be a little bit longer. Right, what I have is a regular pentagon. Okay, so that's probably will come handy. Now, the trick with questions like this, it's if you don't see right away what to do here, you know, just look at the amount of time you have left, and especially with the angles, try to find all the angles that you can. All right? Essentially, we need to prove that ST, which is this, is equal to UT, which is this one. All right? So at this particular moment, I don't know that. However, what do I know? I do know that I can find this angle, each angle in the pentagon. In the pentagon, there's 5 sides, which means there's 3 triangles, and each triangle is 180. So 180 times by 3 is going to obviously gives me 540. And if I divide 540 by 5, I am going to get 108. So this angle is 108, and this angle is 108. Every angle there at T, at S, at R is 108. Okay? Now, also, those lines, this one, how about different color? This line and this line, they are tangents. Tangent is a line that touches the curve only at one point. Now, However, what I do know is that if I had a radius and tangent, they actually have a special connection. Radius oh, my pen is dying. It's not how you spell radius. Radius and tangent meet at 90 degrees. Now, what is radius? Well, radius is the distance from the center to the edge of the circle, right? Now, so that means if I draw a radius there and another radius here, I will not only have a 90 degrees there, but it will allow me to calculate this angle inside, because this angle inside will be 108 minus 90, which is 18. So this is 18, and this is 18. All right, so I'm slowly getting to get all my angles. Now, also, what I've just created over here is this shape over here. How many sides do I have inside the shape? 1, 2, 3, 4, 5. So that means I know all the angles in that shape here, all angles are 540. And guess what? I already have this one and this one. I already have this one being 90. So that means I can calculate this angle. Minus 90, minus 90. So let's do this. 540 minus 108 minus 108 minus 180 will give me 144. Now, there is a circle theorem that says that if you have this situation here and here, but that's not our situation. All right, so that's not our situation, because that line would have to be here. Okay, never mind, this is what I was thinking, but it's clearly not that case. So let's figure out what else do we know. Well, it still helps us. This angle still helps us. 144. Well, if this angle is 144, what is the angle on the other side? Well, angle on the other side will be 360 minus 144, which gives us 360 minus 144 gives us the 216. Why do I care about that? Well, because again, if I know all the angles, I'm pretty sure I will be able to figure out things. All right? So let's try that. So currently I am after to finding this angle. What I mistakenly thought was circle theorem. Now this shape inside here is a four-sided shape, which means all the angles add up to 360 there. So let me take away the 216 that I just figure out, and then I also going to take away the 18 and another 18. So 360 minus 18 minus 18 minus 16 gives me 108. So this angle here is 108. Therefore, angle on the other side must be 180 minus that. So that's 72. And what else do we know here? Now, Actually, it's funny enough, but if you look at this four-sided shape that I have over here, this is actually coming, what I was originally thinking now is coming back. Now, if you look at this shape, there, this is what I was talking about originally. I'm gonna just remove it because it's a little bit too dark. But that shape that I just showed you, it is this situation where you have the center, there is two radiuses over there, there's a one value, that corner is here at the circumference, it's there and there. So this value here is half of this value there. This one is A, this one is 2A here. So this is half of that one. That's one of the circle theorems. So if this one is 144 divided by 2 is obviously 72. Now, what does this tell us? Again, you know, you don't have to be necessarily amazing at maths as long as you develop a good habit in maths. And mistakes happen. I make mistakes all the time. But what I've just discovered is that I am dealing with an isosceles triangle. This is isosceles triangle because my two angles are the same here, which means that's the only option. I have isosceles triangle. I have 180 minus 72 minus 72 gives me 36 degrees for this angle, and this is isosceles. ST equals to TU because triangle TSU is isosceles, and you can draw that triangle 72 72 36 and how you calculated that. I would say that I would probably be better off if you kept your notes a little bit more tidy when you do this, but essentially this is how we solve that question. All right, let's move on to the last one. And the last one is here with has some sort of ratio. Looks very scary, but you have to remember one thing. Ratio, if you check out the actual meaning and where the word coming from, well, it's fractions. So this is, we're dealing here with fractions. I can write this as 2x minus 1 over, so it's 2x minus 4 is equal to 16x plus 1 over 2x minus 1. So we are dealing with just that. Now, when it comes to any questions like this, you can cross multiply here. So we're going to end up with 2x minus 1 and another 2x minus 1, that's lovely, equals 16x plus 1 and x plus minus 4. All right, so let's expand this bracket. We are dealing with that. So when we expand the bracket, we're always going to have first term squared. Then you're going to have plus 2 times everything inside those two terms, and then you're going to have last squared, right? So we are dealing with 2x squared, which is 4x squared minus 2 times 2x is 4 times minus 2 minus 1 is minus 4, so it's minus 4x and then plus 1. Here we need to expand everything. So we got 16 times x, 16x squared minus 16 times 4 is 24, that is 64. Yeah, 64. 64 x. Then we got this multiplication, which is just x. Then we got minus 4. I am going to move everything to the side that's gonna give me a positive x squared. Because if I, in school, the intuition will tell you to move everything from the right to left, right? But you really don't really want to do this because you're gonna end up with minus 8x squared. Not 8, minus 12x squared, right? 4 minus 16. But then you're dealing with a minus. You don't want to be dealing with the minus. So I am going to move everything to this side, which is going to give me 16x squared minus 64x plus x minus 4. I could have tidied up, but, whatever. X squared minus 4x plus 1. And now I'm going to, those are my like terms, and this is my like terms, and there we go. So I got 0 equals 12x squared, so that's that one done, minus 64, so that gives me minus 63x, and then I made a mistake here, look, minus 4x, so it's plus 4x, there you go. So plus 4x, that gives me minus 59x, and then minus 4 plus 1, and again I made a mistake here. What's going on? I think I'm getting tired at the end, so double check your answers. When you move the plus 1, you obviously minus 1. Oh, Jesus. And then minus 4 minus 1 is minus 5. I don't know, sometimes like the intuition tells you that that you can, there's something wrong here, that something just didn't feel right. All right, 0 equals something is the same as something equals 0. So let me just make this look from the left-hand side. And now what we are praying is that this somehow will factorize. Now, when you factorize, I've done this a million times, so I'm thinking to myself, like, how I can do it, right? Now, with 12, with these two first numbers, you can have this option, but you can also have 3x and 4x, because that's going to give you. You can have also 6x and 2x. So there's many options. You cannot be lazy. You have to try. But with the 5, fortunately, we only have two options. We have 5 and 1 and 1 and 5. And obviously with the other guys, we also could have x, 12x, 4x, 3x. Because the order, it does matter here, 2x and 6x. So now the most important part is to be aware of how we create this value. We create it by multiplying this term with this term and this term with this term. So that's what we're going to check it. I am going to place here 5, and 1, and we'll see what happens if I can make 59 out of this. 12 times 1 is 12. Let's skip the x for now. 5 times x is 5. Can I make 59 out of this? There's no way. Even if I put plus, minus, minus, plus, it doesn't matter. I will not make 59 out of this. This means that we need to reject this option. Reject the 5 and 1 with the 12 and x. So I am going to now try a next option, which is I had 5 and 1, so I'm going to do 1 and 5. And the reason I'm doing this is because 12 times 5, it gives you a big number, and 59 is a big number, right? So if I do 12 times 5, well, what do I get? I get 60. And 1 times x gives me 1. And guess what? If this was a minus and this was a plus, I will get my minus 59x. So how do I get minus 60? Is this multiplication must give me minus 60. So I must have a minus 5 here. And I want a plus 1, so I'm going to put plus 1 here. All right? So now all of this is unnecessary anymore. We don't need that. And I would normally keep it, but I need space to finish this question. And I feel, there we go, this is the last one. Okay, so now to solve this, we're going to make this equal to 0. Minus 1/12. And this is going to be also equal to 0, which is 5. And this is our solution and our specimen paper tool hire completed.